Scenario: a student places a block on a ramp with a rough surface and let it go, but the block doesn't move. Question: you're going to explain using forces why the block will remain at rest. At rest means there is no acceleration, so A is going to be equal to 0. So you can say that here the gravitational force isn't strong enough to overcome the static friction force. So the object will remain in static equilibrium. The second question states, what is the possible values of the static force of friction? You're going to select two answers. Let's do the free body diagram on the block. What is pulling it down is going to be the x direction of the force of gravity, which is Fg sine theta. The one going towards the ground, which is perpendicular to that, which is going to be Fg cosine theta. Going opposite, because here it should move in the x direction down, so in the opposite direction would be the force of gravity. Mu of static friction times force normal, but force normal is mg cosine theta. If you take a look here, you can set it up before using a equals to 0. So the acceleration is going to be equal to the sum of the forces divided by the mass. Okay, multiply m to the other side. You have ma is equal to the summation of the forces. This becomes 0. You have all the forces here. What you have is force gravity minus force friction. Add force friction to both sides. You now get this version. Mg sine theta is equal to mu s mg cosine theta. This is what happens when it is equal to 0. This is in equilibrium. There's one more answer. This is what happens when the force of friction is greater than, this is the greater than symbol, the force of gravity that is down the ramp. Okay. Because that is the only part that's actually bringing the object down the ramp. The last question, what is the value of the force of gravity in this scenario? The force of gravity is going to be this part, which is just Fg. Doesn't ever change. It's just mass times gravity. Please note that the total forces exerted on the block by the incline is supplied only by the gravitational force. Nothing else moves the block but the gravitational force. Specifically, it is the x component of gravity that is moving the block down the ramp.